peroxide, which will break down on its own into water and oxygen gas. Now you can buy hydrogen peroxide at the drugstore. When it's purchased there, it's 3% by weight hydrogen peroxide. They sell it to disinfect wounds. Turns out data are important, and it's actually not any better than just using clean water, but there it is. So I'm going to modify today's procedure a little bit though, because I'm going to do it for you in a demo format. So your experiment uses the 3% that comes from the drugstore, and then uses the catalyst, or uses for a catalyst, regular yeast from the kitchen. And that certainly works, and you can do that version at home if you're looking for a way to do it. If you want to do a little science and kitchen chemistry while we're all here teaching remotely, you can follow that procedure, and it's safe to do that. I want to up things a little bit, and so instead of 3% hydrogen peroxide, I'm going to use 30% hydrogen peroxide. This is not something that you can purchase. In fact, the general public can't get anything over 12%, which is used for bleaching hair and things along those lines. So you have to be very careful with this stuff, especially the 30%. So what I'm going to do is I'm going to put it in here. And I have no idea how much I put in here. Based on how I'm doing this experiment in the past, I know that I'm putting about 100 mils in here. So let me add just a little bit more. Let's get it up to 150. There we go. Okay. Now, this reaction happens on its own. Hydrogen peroxide will break down to form hydrogen, so as I say, water and oxygen gas. However, if we look at it, we don't see any bubbles. There's a couple little bubbles in there just because of how I mixed it together. But let's see if we can add a little bit of soap maybe, and that might help capture some of the bubbles. So let's put that soap in there. Let's get a good squirt of soap. All right, regular dish soap that works here. I like to use the yellow just because you'll see some more things here in a minute with it. Now, if I bring this up to the camera, you will see a few bubbles around the top. Turns out that's just from my mixing it together like this, and I've trapped a little bit of air in there. We can do the reaction over time, we can watch it, and we can see that in fact it is very slow. In fact, this reaction takes several months to take place. So we would be waiting a long time for this to go. So how do we catalyze the reaction? Well, this particular reaction can be catalyzed two different ways. Well, more than two, but two we're going to talk about here. One is by light. And so it can actually be photocatalyzed, which is why when you buy hydrogen peroxide, it always comes in a brown bottle. And that's to prevent light from breaking it down. And that will speed up the reaction, but not very much, just a little bit. So I want to see if I can speed it up a little bit more. So we're going to use a chemical catalyst. And in your lab, it talks about using the yeast. Today I'm just going to use potassium iodide, just works a little bit better here. But before I do that, I want to add a little bit of color to it. So let me just grab my food dyes here. So have a little fun with this, put a little color in here, a little bit of red, and then, well, wherever, so we got some blue, that. All right, so I've got it streaking down the side. So now what's going to happen is I'm going to add my potassium iodide, and we're going to see if we can take this reaction that normally takes months to go faster. Remember that a catalyst reacts or helps the reaction go place in a higher rate by several different ways. One of which is providing just an alternate reaction pathway. Another is physically bringing the molecules together, so overcoming the collision frequency. More about that in class, but let's see what happens now when we add a potassium iodide. All right, see if we can get the reaction to go a little bit faster. And, whoa! Stay in the bottom. Okay, definitely a faster reaction. Okay, bring this on up here so you can see that. It's still going. Oh, wow, I added a lot. We see some colors that looks a little bit like Aquafresh. Now, you may have seen this. Well, there's a lot of examples on the internet. I'll actually link to a video. One of the things I love about the internet is that there's always idiots out there that are willing to do stupid things. And there's some people in Malibu, California that did this on just a ridiculous scale. It's kind of so out of control that they're actually being sued by their neighbors. So I'll put that in there. The other place you may have seen this is that this is the chemical reaction that the Miss USA did to win her title this last year. Now, one of the things that we saw here is that the reaction definitely sped up. It's an exothermic reaction, gave off a lot of heat. But my catalyst was potassium iodide. Now, for those of you that have taken biology, you know that a way to test for the presence of starch is the iodine test. And so I just have a paper towel here, because I kind of need to clean up a little bit of my mess. And if you touch the paper towel to this, you can drop it in there too. So if we touch the paper towel to the foam that has the potassium iodide in it, so we're essentially doing the iodine test, and you look at the paper towel, you can see that it's definitely turned black, and that's the starch test.
So for that reason, we decided just to put all the numbers to rest and just go insanely big. So for today's experiment, we're using 625 liters of 35% hydrogen peroxide, which is 245 liters more than Mark and Science Bob's last attempt, 15 times more than Science Bob's 2018 attempt, and we're also using potassium iodide, the more potent catalyst. Today is gonna be totally insane.
This is it.
Alright, so what we're gonna do next, we're gonna add the soap. All of those bottles right there should be 29 total.
Like, why is it not working the plastic?
That's it.
Man got hurt.
In 3, 2, 1, go! Oh my god! Oh my god!
The most insane thing ever.
I didn't know that! I didn't know that was gonna happen!
It's in the sky!
Oh my god! Oh my god! It's flying away!